Yash Kamal. I am currently a third year BTech student from BMS College of Engineering, as well as I am AI intern with the CellStrat. So I welcome you all. Thank you for attending it. So for the today's topic, we have abstractive text summarizer. Okay. So before starting the topic, let me tell you something. Okay. How can you relate it? Suppose if you want to visit a restaurant or anywhere, what you want? You wanted to know whether it's a good place to visit or not. Okay, so what you want? You will open the Zomato, you will see the review. So there are a lot of reviews over there. Okay, so you can't rate the whole reviews, like there are thousands of reviews. So what basically you want to know? Yeah, it's a good restaurant or not. That's it. How's the food? Yeah, it's yummy. That's it or not. So you just want to get the important point out of that, not the whole review. So basically the text summarizer, abstractive step summarizer will do that for you. So basically the text summarizer is of two types, extractive and abstractive. So what's the major difference between these two is in extractive, they will just extract the important word out of that. Okay. So suppose there is a word I love to play cricket. So they will just pick out the important word. But in abstractive text summarizer, they will summarize it. Okay. So they will basically give the summary of it. Okay. So that's what the text summarizer is a task of producing a fluent summary while it preserve the key information. Okay, so it basically focus on the overall meaning of the sentence. We identify the important sentence of the phrases and extract that text from, like, we have to, the main point, we have to preserve the sentiment, like what the actually the uh, reviewer want to tell. So the main task what we are doing is to prevent the preserving the sentiments and the point, and that extracted summary is will be our the required summary. So what's the problem statement today? So as I told you, the as I told you, the customer reviews are often very long and descriptive. Okay, so analyzing this review manually, you can imagine it's really a very time consuming. That is what the brilliance of natural language processing comes into picture. You can just create a summary of the very long picture, like very long reviews into a very short reviews. Okay. So what all are the concept used in this? Like before going to the code demo, before telling all this, let me explain you some of the basic concept which has been used throughout this model. So first one is attention mechanism, second one is stacked LSTM, third one is embedding layer, fourth one is tokenization. So basically what is the attention mechanism means? So attention, as the name indicate only, give the focus on something and taking that into the greater notice. Okay. So the attention mechanism in the deep learning, it pays the greater attention to the factor. Like suppose the statement is there, I love to play the cricket. In this, to whom should we give the attention? So it should be obviously love and cricket. Okay. So basically the attention mechanism do that for us, because in the review we have to get the important point out of that. Okay. So attention mechanism can be of two types. One is general attention and second one is the self attention. So what the general attention is between the input and output element, like both are involved in that. But the self attention is within the input element only. Like we are not including the output element. On the input element, we are providing the attention to it. So that's the basic first concept that we are using it. Second one is LSTM, stacked LSTM. So I'm sure that you might be knowing about LSTM. So why stacked LSTM here? So the thing is that in LSTM we have a single hidden layer. Okay. So the stacked LSTM is nothing but it's the extension of the multiple hidden layer. Like there will be the multiple hidden layer. Okay, and each layer will be containing the memory cell. Okay, so basically stacked LSTM makes the model more deeper, more accurate. Okay, so the what matter is the accuracy. So by applying the stacked LSTM, we are getting the more accurate results. Like because it have the many hidden layer. Okay, so basically we'll proceed the text very in a very good way. So we are producing the output a very good output. So the third concept which is used is embedding layer. Okay. So you might be knowing about one hot vector. That is conversion of, like, we are converting into the matrix. So the what you say is, okay, so the word embedding is basically a representing a word or document using a dense vector representation. The thing is that why we are doing that, we are using to, like, we have the input feature. Okay, and we can't have a vector like 8,000 unique word in the text classification problem. Okay, we can't have the, what you say, in a one hot vector or something like that. This approach is more like, it will take a more memory. So to cope up with that, we have embedding here. Okay, so embedding layers basically is a memory intensive. Okay, and the matrix will be the sparse and the sequence of the sequence. Okay, so basically it use the dense vector representation to do so. Next question, next important point, what we are using is tokenization. So tokenization is the process of dividing text into set of meaningful pieces. These pieces are called a token. Like example, we can divide a chunk of text into a word, or we can divide into the sentences, depending on the task. Okay, so here we are dividing into a sentence into a text. Okay, so basically it is used to get the word boundary, ending a point of the word, beginning of the next word, or something like that. So how you're using it while giving the code demo, I will explain it where tokenization is used. Basically, it is like dividing the sentence into chunks of word, okay, so that we can get the word boundaries, what actually it is. So how to implement it? So I have discussed the four basic concept, what all it is come. So the next part is what the how should it be done? What all we are doing in the code to do that. So the first important part, as every model you will implement, first you have to clean the data. Okay. So that also we are doing over here. We are cleaning the data. Okay. Next is we have to understand what is the sequence, what all data we have, what all we have in the data set. Okay. So we have to understand the distribution of the sequence. Third one is preparing the tokenizer that I told you, like how we want to implement it. The fourth part is model building. Like we have to see, yeah, we have to build the model. Okay, so now we have to encode it, like in the encode it into a, like what I told you. Next come the embedding part. Okay, the embedding part will get into a vector, and after that all the processes will be done, and at last we will decode it. Okay, decoding it means from the vector we are getting back to the text. Okay, we are using that like from the attention mechanism. Okay, so how your output will be, see, review is use eat flex brownie, horizontal milk brownie, super easy, make taste great, since like dark brownie usually a little avoid. Original someday is delicious brown. What we are predicting is best brownie mix. So you can see it is something similar to that. The original should be delicious brownie, but what we got is best brownie mix. So you can get to know from the review, yeah, brown, where we are going is the reviewer is talking about the brownie, like the brownie is best, so we must try it. Okay, so that's the basic concept that are covered in this. Okay, so basically in this topic, there's, while giving the code demo, I will try to explain each and every concept at that time, so you will get a better idea about it, like what is happening in the code. So I will jump to the code. Okay, Okay, so let's start the code demo. So we have taken a sample of 1 lakh reviews. Okay, you can take there is a predefined Zomato reviews sample which is given by the Zomato to train instance. I have 1 lakh sample. You can took as many as you want. It's up to your computational power of the system. I took it as a 1 lakh. So what all we have in the system? As you can see, we have ID, product ID, user ID, profile name. Okay, these all are there in the review. Okay, summary, the original review. Okay, so what I told, we have to clean the data. So the cleaning process starts there. First of all, what we have to do, we have to delete the like duplicates. Which all are the duplicate one? We have to delete it. And any value, like wherever it is empty, we have to do that. So we did that. So we have got that. We have after removing it from 1 lakh, we have got to the number as 88,421. So after removing the NA value and repeated value. Okay. Now the thing is that what we are doing is something called contraction method. So basically, we are you can see it here like aren't. So we are expanding it into a form can't, cannot, okay, cause because. So while like giving the review, you have using the source and all. So we will try to do that. That is known as contraction mapping. So we have a set of contraction mapping of the words, what actually it is. Okay. And convert something like to pre-process the data before we have to do something. So first of all,
Yes,
we will try to convert everything to the lowercase level. Yeah.
yes.
Hello.
Would you be
Yeah.
able to
Yeah.
share the link for the code?
The thing is that it's on my the local drive. After the once the webinar get over, I can share it all. But because again, it take a lot of time to share the code.
So, do you
At
have
the
it
end
on
of
your
the
GitHub
webinar, I can.
profile?
Yeah. No, no, no. I have it on my drive.
Okay. So, what we'll do is you post it on the meetup link itself when you have loaded it to your GitHub. Okay.
Okay, okay, fine. So after the webinar gets over, I will
Yeah, yeah,
upload it into my GitHub account, and you can access it, and you have any. Okay.
yeah. So you
So the
can give your
thing is
GitHub
that
link
we are
on the meetup.
okay, okay, fine.
Yeah, thank
So first of all, we have to convert everything to the lowercase letter. The thing is that we want a similarity between the text. The second one is removing HTML tags. What all HTML tags are there? Third part, the contraction mapping, the one I explained it before. The fourth one is removing the S and all that. Okay. So the fifth one is removing any text behind the parenthesis. Why we are doing that? Because sometimes using the text, you might use some word. Again, in the bracket, you will tell something about it. So again, it won't be better while training our model because we are giving the attention to the words. So more attention will be paid to that word because the similar thing we will put into the bracket. So we will remove any text inside the parenthesis. We will remove the punctuation and a special symbol. Stop word should be removed. Short word should be removed. So the thing is that I've imported NLTK library. Okay. So I have downloaded the stop word thing. Okay. So what all I have told, I am removing it. Remove. You can see that using the re.substring, we will remove the all the sub the thing which I told the HTML tag. We have to just convert it into all smaller packages. This all is happening over here. Okay. So after that cleaning of data, now I'll try to print some review. 5 reviews I'm printing. As you can see, I bought several VLT cannot dog food products for any good quality. As you can see, all are in the lowercase letter. No short form is used. No this S is used. No bracket. So this is the similar kind of text. So you may ask why we are doing it. Just for the getting the better result. If we will do that, our output will be more perfect because we are training a machine. So the while training, how much good data, how much clean data if we'll provide them, the output will be more better. Okay. So now I am the same thing we will do for the summary. Summary, the one we have got it. Okay. So as I have shown you the data set, what all we have. So in that we have the review as well as the summary. So we are doing as well as this for the summary part. I'm printing 10 of the summary over here. As you can see, good quality dog food, not as a like it all is printing is over. Okay. Now this all are the again the data head. What all data head we have ID, product ID, text, clean summary. Okay. So you can see that summary good quality do food dog food. As you can see, G, Q, D, and F are like capital in this, but in our clean summary it is small. So till now it's going fine. Okay. So again we will replace the empty rows again after this. Okay. So the thing is that we after all is done. Okay. Now the thing is that we have to understand the distribution of the sequence. That's the second important part. Distribution of the sequence, basically what I mean over here is we have to know how many, what is the length of the review, what is the length of the summary, like we have to get it because while taking the output we should like get know how many line of output we want, what side of summary should be fed to it. So for that we have plotted a graph, okay, between the summary and text. As you can
Yes, one
see that,
question.
yeah.
Can you please explain how the text is made into summary and how is it split? Which function is used for it?
Okay, so basically, the thing is that I guess many of you are confused with it. Let me clear it. We have a data set. In the data set, okay, in the data set, we have already the summary as well as the text. Okay, so what we are, it is a kind of train model. Means we have already given a summary as well as the text. And now I will like by this all, I will at last, I will print my own summary, what my model is generating. And I will compare it with the original summary, what we have got it. Okay. So as you can see it here, this part, it's the input part, ID, product ID, user ID, profile name, time, summary, text, clean summary. Okay. But there are around 88,000 of this data. Okay. So from getting that data, we will try to produce our own summary. Okay, what summary we are producing by our model using our concept. Okay. So this part is basically that. Okay, we have already given the summary as well as text. And again, we are producing our own summary to get the what actually we want to see whether how much percent it is matching to our summary. Okay. So I hope I cleared it.
Sure.
Okay. So basically, so basically the distribution of sequence we have to understand means out of the 88,000 or 80,000 summary, 88,000 review, we have to figure out what is the average length of the summary, what is the average length of the text. So after plotting a graph, we can see that the summary review like 8 is the like 8 words, like maximum review, maximum summary is of around 8 words, as you can see in the graph. Okay, so if you try to find out how many percentage of summary, like we will fix it to 8. Okay, so I will like apply the for loop and if condition, in that we will see like how many around in 88,000 summary, how many of are less than 8 or equal to 8. So we have found that around 94% are that. So we can say that 94% of the summaries are below length 8. So we can fix that maximum length of the summary to 8. Okay. It's up to your wish how many lengths, like you can fix it to 10. But in the maximum length 8, so I fix it 8. Okay. And we can fix the review length to 30. So it's fine. So we have got the two things. Till now, what we have done, we have cleaned the data, we have pre-processed it. We will try to get the length. So after getting the summary and text length, we have got that 8 is the, we have fixed the max text length as 30 and maximum summary length as 8. Okay. So now we have to select it. Okay, fine, we have got it. Now what we have to do? Again, elimination part will come. From 88,000, we will try to reduce it to, we will take consideration into those whose length is 8 and maximum length is 30. Okay, so we will do that here. Okay, remember I have taught something about the tokenization. Okay, so here the comes a picture for the tokenization. Okay, after like what you see, after selecting the reviews of length 8 and uh, so after that what we will do, we will add a start and a special token to the summary at the beginning and end of the summary. But make sure the word which you are attaching to the start and end of the summary, it should be the unique word. It should not be something like which will be existing in the text already. So I have chosen the source stock, e stock is something two words which will be our act as our start and end token. Okay. So we will apply it to our whole summary part, what all we have. Okay. So basically now we are till that it is done. Means we have got the perfect data. We have got the data set, how many data set we are having it. Okay, so we have tokenized it, started like starting and ending part, we are doing the token part. Now we are going to the model building part, that is the third part. So the thing is that as you have to divide it, so I have took a 90% as a training data and 10% as a remaining, like we have to check is the evaluate the performance on that, basically what we do over here. Okay, so there is a distribution of 90 and 10%. Okay, so I have did that. Okay, so the thing is that a basically I have discussed the tokenization. So again, what is tokenization? A tokenizer build the vocabulary and convert a word sequence to the integer sequence. Okay, so that part is going to be done. So next part, what we will do is, okay, so there will be some of the rare words. Like everybody types used to type the review in some other way. They might use some word which is not understood by everyone. Okay. So what I am doing is I am defining a threshold to be 6, which means word count of which like which is below 6 is considered as a rare word. Okay. So because we have to eliminate the rare word. So after
Yes, one
removing the,
question.
we have found, yeah.
Why are we adding tokens here?
Okay, so why we are adding the tokens over here? So that is the question. Okay, so we are adding the token E stock and S stock at the last. So just wait for 5 minutes at the like while proceeding. I will tell that at that point why we have used it. So we will understand it better. I noted down your question afterwards. Okay,
Sure.
because again I have to move to the other point of the code. It's at the afterwards it will cover why we have used the token ID. Okay,
Sure.
so basically the we have to take the rare word. So we have found that which count is below 6 is considered as a rare word. So we have found that uh, total percentage of the rare word in the vocabulary is 66% and coverage total coverage is 2.96%. Okay, so what all we have done, we have found the rare word. Okay, so we have put the threshold to be 6. Okay, fine. So now we have to do is we have to again, what I told is uh, we have to convert the text sequence into the integer sequence. That the tokenizer did. Okay. So what we are doing is we are padding it to 0 up to the maximum length. Okay. And after that, we will get the vocabulary size is 8440. Again, the same thing we will do for the summary. Okay. So we will cover the summary tokenizer as well as. Okay. So here I am defining the threshold to be 6 for the rare word, means which count is below 6. Okay, it's considered as the rare word. As we can found it, like it's the in the coverage, it's in the summary part. The below above one was for the we have to as well as find the rare word in the summary as well as in the review. Okay, so as you can see that in the summary the percentage of rare word is 78%. Okay, and total coverage is 5.39%. Okay, so the thing is that now the token picture comes into the picture. You have asked why we have did the start and end token. Okay, fine. So the thing is that start and end token. We have added the start and end token of each and every summary. Okay. Now what after that we did? We have eliminated the rare word. Okay. And all that we did. Okay. So after that, how come we will know that the our summary is empty or something like that? Okay. So what I will do that I am deleting the row that only contain the start and end token. Means what token we have added, if the summary contains that only, means there is nothing else beside that, we can delete that. Okay. So that's why we are adding the token, okay, at the each and each start of each summary and end of the summary, so that we can get to know that which all are the empty after data, like what all we are doing to after a rare word coverage and all that. Okay. So I hope I cleared that point why we are adding the tokenizer over here. Okay. So we are found that around whether let us check whether the word count of the start token is equal to the length of the training data. Okay. So I am deleting
Yes,
now the start.
Yes, can
Yeah.
you please explain that again? Tokenization?
Okay, fine. So the thing is that we have added the start and end token at each and every summary at the beginning, which I told you. Okay, at that time you asked why we are adding the tokenizer. Okay, so basically after adding the tokenizer, what we did, our next step, we have to take the rare word, which all are the rare word. I put it as a 6. Okay, so after that I cleaned the sentence which have the rare word equal to 6. Okay, now the thing is that after removing the rare words, if suppose our summary is empty, how come we will know that our summary is empty, it doesn't contain anything? So what we are doing is we are adding the start. We will find, we will like apply the loop, and we will check if the starting part is like, if the summary is having only the token start and end token, means there is no summary inside, we can conclude that. Because okay, so we will eliminate all that summary because it is empty. Okay, that's why we are adding the token part. Here I am deleting the row that contain only the start and end token. I hope I cleared it. Okay. So basically I'm deleting that row that contained only the start and end token in the both the summary as well as in the what you say, text. Text means the review which has been given to us. Now we are moving to model building part. Okay, so basically something is called like something familiar term we have to get to know, that is return sequence, return state, stacked LSTM. So stacked LSTM has a multiple layer of LSTM stacked over one another. Okay, so the thing is that why you are using the stacked LSTM, this is used to the better representation of the sequence and we are getting the more perfect output. Okay, so the output what we are getting is more accurate because it has most the hidden layer. Okay, so we are doing the stacked LSTM part over here. Okay, so now the thing is that you have to apply the, we are here, you can see I am using the 3 layers, building 3 stacked LSTM for encoder. You can use 4 or 5, but make sure that while increasing the layer of LSTM, if the output part is getting more better, so it will be very good. If the output part is not improving, so there is no use to get, like there is no point of using the stacked LSTM, like increasing the layers. So here I have used the 3 stacked layer. Okay, as you can see, LSTM layer 1, LSTM layer 2, LSTM layer 3. Okay, and we are adding the attention layer, attention which I have told you to give the attention to some particular word, the important word. Okay, so as you can see, we have got the our some of the model summary. Key, what are the output shape, how, which layer it is getting connected, as you can see, like uh, because all the layer will be connected to each other, all LSTM layer, because all are the hidden layer, they all are interconnected. Like what we are getting from the hidden layer 1, we are passing it to hidden layer 2, same thing. So the same thing it is producing over here, like the
Yes.
it's showing the connection, which yeah.
Are there any other options besides LSTM?
Yeah, yeah, what, can you repeat
Uh,
it once again?
what are other options besides LSTM?
Okay. See, the LSTM basically it's the forecast the part. So we can use that. ARIMA also can be used inside of LSTM. I guess the ARIMA will also work because the work which is produced by the LSTM is the same which is produced by the ARIMA. So I guess ARIMA can also be the use to that. But LSTM will be produced the it's the more accurate. So LSTM will give the more accurate output. You can use the ARIMA for that. That doesn't create any issue. We are using LSTM. The main difference is that we have to increase the hidden layer in that. Okay. So in the LSTM, we have something called stacked LSTM. That gives us the chance to increase the hidden layers. That's why we are using the stacked LSTM in that. You can use ARIMA also, but I am sure that it won't give the much accurate output as we are getting in this. I hope I cleared it. Okay, moving next. So I told you I am the layer interconnected. Try to hear it is soon. Okay. So the thing is that the main part come. Okay. Which optimizer we have to use? Which loss? I am using the something called sparse category cross entropy as a loss function. Okay. Why we are using it? Because it converts the integer sequence into one dot vector on the fly. Okay. So basically the thing is that we are using the sparse category like as a loss function because see here is the word. While dealing with the integer, you can convert simply into a vector so that it will be very easy. But here the words, every words will be different. Okay, so there will it will require the more memory. So we have to overcome the memory issue. So we are using as a sparse categorical cross entropy as a loss function, and we are using the optimizer something called RMS prop. Okay. So you might ask why did we use the normal gradient descent or something like that. Okay. So the thing is that this function restrict the oscillation in the vertical direction. Okay. And so that therefore it's increase our learning rate and algorithm could take the larger step in the horizontal direction conversing faster. It means that like suppose there are lot of many data sets. Okay. We have to proceed it in a very good manner, very fast manner. So the thing is that if you use the normal gradient descent, it will in the vertical direction it will go more deeper. Okay, but RMS prop will restrict that. Okay, so our like what we are our algorithm could take the largest step and produce the output in a very faster manner. Okay, remember something called early stopping. Okay, those who are not knowing, I'll explain what is the concept of early stopping we are using over here. Okay, it is used to stop the neural network at the right time by monitoring a user specified metrics. Okay, so the thing is that suppose while going by training the model, okay, so sometimes if we'll degrade it, so we have to fix the point. Okay, if it's if the loss is this much, like at that point you have to stop it. Okay, so sorry. So here the comes a picture of early stopping. Okay, so we have to stop the like neural networks at the right time. Okay, so we are using the concept of early stopping over here. Okay, loss function is a sparse categorical cross entropy. Optimizer is RMS prop. Okay, these three things which are using over here, which you usually don't use in any other model. Okay, so fine. Let's move further. Okay, so we have proceeding it. I've already like run it. So we are proceeding it in a batch size of 128. Okay. And as I told that 90% will be the training part and 10% of will be the validation part. Okay. So I'm running all the epochs. I've already run it. Okay. As you can see here, after running it, it's showing at this epoch, we are doing the early stopping. Okay. So means the thing is that uh, we are using the early stopping for that at this point of time. Okay, so it will show that also. So after running the epochs, it is maximum part is done. So what next? We have to build again the dictionary, that is the coding part. We have to get the what you say source vocabulary from the index of the word. Okay, so we are doing the encoder model over here, encoder and decoder part. Okay, So basically, encoder and decoder part that we have converted it into a matrix form, or what you say, we have embedded it. Okay. So again, we have to decode it to get the, what you say, the output. So we are getting that part over here. Okay. So something called attention interface is also we are using while getting extraction of the output, the summary. We should use the attention interface. Softmax layer is also used to generate the probability distribution over the target vocabulary. Okay. So we are defining a function below which implement the interface process. Okay, interface process means the, what I told, the everything is converted into vector and all that. Again, we have to get back to the normal vocabulary, normal sentence. We have to get that. Okay, so what we will do is, uh, the thing is that here I am getting the summary. So the thing is that as you can see it, briefly, I'll tell you what exactly it is. Okay, so normal C++ code what we are running is using the for and if loop. Basically, it is doing that in the same in the Python. Remember, I have added the token at sock stock and end of stock. So after all, we have to get the summary of that. So what I am doing is over here, you can see if sample token is not equal to end of stock, decode center is equal to sample plus token. Means until it doesn't reaches to the end of this, we are adding the decoder sentence, like we are adding all the tokens into the decoding sentence. Okay. So we are adding the exit condition also. Means if it is reaches at this condition and length is greater than maximum summary length, we will stop it. Means suppose, remember I have said the length of the summary should be this much. Okay, fine. So we are doing that over here. Okay, we are specifying the conditions what all we want. Basically, moving a for loop, applying if condition. If it reaches at end of the point, we have to stop it. Okay, so normal C++ thing over C++ Python normal thing is over here. Okay, which is very basic to understand. Okay, so here the tokenizer part is most important, because from that only we are able to determine where it is starting and where it is ending. Okay, fine. Now, okay, now the thing is that we have to consider the integer sequence to word sequence, as well as for the reviews, as well as for the summary. Okay, remember we have converted into a integer sequence. Now we word into the word sequence. Okay, so I'm doing that part. Okay, and now sorry, now the few of the summary which is generated by our model. As you can see, how's the output is. Got great course, good Belgium chocolate butter. Ordinal somebody, would you like to get it start? But predicted somebody is yummy. Our one best flavored coffee tried usually like flavored coffee. One great serve company loves. Original somebody delicious. What's the predicted somebody great coffee? Okay. So as you can see, somebody test or unpack art. Turkey
One
means,
question here, please.
yeah.
Uh, can you please explain the source vocabulary part again?
So vocabulary part again. Mm, mm, mm. Okay. So the thing is that let's build a dictionary. We have to basically, what actually we are doing over here in the source vocabulary is we have to build the dictionary to convert the index of the word to the target and source. Like suppose we have to see, there are so many different words over here. Okay, so we have to find out which words resemble similar to that. Okay, so basically that part is done over here. So the thing is that we are building a dictionary in that what we are doing is we are converting the index of the word to target and source vocabulary. Like what actually we are getting is like a source vocabulary, like there's some vocabulary for that. We're storing it in the dictionary part so that similar words resemble the same. So while producing the output part, it will be very better for us to get the similar words, similar meaning. We can't have a good, suppose good, yummy, awesome. Like this all words resemble the same thing. Like user is happy. Something you have to get out the main funda is that you have to get the sentiment, like what actually it is, whether the reviewer is happy, whether the reviewer is sad, whether the reviewer is moderate. So basically we have to extract the sentiment part of that, like what the sentiment of the user is. So that is the main part for that. So again, so that in that you can see maximum of summary what we are producing is of the same word: great coffee, great product, great product. See, something negative review came, not the same as expected. Original summary is tail. Okay, so you can see that not as same as expected means they're by doing model training on 1 lakh data. If I am able to get this much, like I know it's not so accurate, but it's pretty much by resembles to the original summary. It's not like opposite sentiment analysis. Like it's not like that. Suppose it's telling that user is happy with the product. I am printing this. It's not happy. So you can see it's tail. So not as the same as expected. Wonderful. Okay, so the thing is that the my cat loved this food means she might have, the user might have something bought something for the cat and all that. Okay, so you can see that green is body treat, green treat, dogs love them. Sometimes it's printing the same thing. Okay, so makes great cup of java, something like that, great coffee. So as you can see that the thing is that it is producing a resemble output. So you can see it. Yeah, yummy means it's good. One line, one word. Salty, something. So it's getting done at this point. So I guess I'm done with it. Yeah, as you can see, the original summary and predicted summary. So if you have any questions or anything to ask, you can ask it. I'll try to answer it.
Can you show us the dictionary?
What?
Somebody is
Can you?
asking, can you show the dictionary?
Okay, so the thing is that uh, I'm not printing the dictionary over here. So it's a basically again it will be the views dictionary. So the thing is that uh, it will be the word like kind of what is it? Not exactly the vector type of thing, but something in which we can add the, like we have added the tokens and all that. So it will, like it will a very huge data set for the dictionary as well, as because there are 1 lakh reviews. Okay, so in 1 lakhs we are creating the dictionary for each single word. So it's a very huge part to print the dictionary. So I'm not printing the dictionary over here. Okay, so I'm just like uh, we are building it and we are using it in our model. I'm not printing it.
Audience, any other questions? Any other questions you can ask now, or else he'll be sharing the code link on his GitHub
GitHub.
on the post of the meetup. Yes, people are asking your contact details. Can you show your contact details on the slide, please?
Okay,
And
one second.
as mentioned earlier, this session is being recorded and will be available on the CellStrat YouTube channel. I'll just share the link here.
So basically, you can find me on the Yash by the name of Yash Kamal in the LinkedIn. Okay, I will add my contact number as well as my email address over here only.
So I have shared the CellStrat YouTube channel link. You all can come back in 3-4 days time and you will be able to find his webinar recording there.
So you can see this is my contact number 8987054269, and it's my email address. And like it's my same by the name of Yash Kamal. My LinkedIn profile also you can find it.
Any other questions, audience? Yes, you have finished it well within the time. So look
Yeah.
forward to more
So
such webinars in future. So any other questions? Otherwise,
yeah,
we'll close the webinar.
yeah. Thank you, audience, for attending it. It was great experience working with this somebody. I guess I'll share the link. I'll I'll request everyone to try to run it in the local computer. Like basically, I was also not knowing much about NLP. This is my first project on the NLP, which I am doing. Earlier one I've already presented on the YOLO detector. This is first time I'm working with the NLP. So my experience with NLP is very good. Okay, so I was also facing so much of difficulty while running the code. I've got so many errors, so many part I got stuck in what actually it is doing. So what's the best part? Vivek sir used to tell us what we follow is the thing is that wherever you are having the doubt, just copy the same thing and paste it in the Google. You will get to know so many things, like how I came to know about early stopping and all that from that part only. Like I used to just copy this word and I used to paste in the Google. I used to get the whole thing. Okay, it is like that. Okay, so we used to again go into our model again and again, so what actually each step is doing, and so by that thing only you will get to know much more about that topic. Okay, I hope you have liked it. Okay, so
So some people are asking, what is the difference between text summarization and abstractive text summarization again?
okay, so the text summarization can be classified into two parts. One is extractive text summarization. Second one is abstractive text summarization. So extractive text summarizer, what it does? Extractive text summarizer is that, see, I will give a basic example which I give in the start. I love to play cricket. So extractive text summarizer, it will take the love cricket, the more important part. It will take some words from that. But abstractive text summarizer, what it will do? It will generate the summary for that loves cricket, something like that. Okay. So it will generate the summary out of that rather than picking out the some important words from that. So you have seen in our model while printing the output, it was some not exactly some words pick up from that. It's some other word which we are generating it. It's some other words that is coming into the picture. If you are using the extractive text summarization, so from the output from the output predicted summary we will get it will take some word and it will print it. So that's the major difference between the abstractive text summarizer and extractive text summarizer.
Okay, and you had mentioned YOLO before. So somebody is saying,
Yeah.
can we have a YOLO session also? So I would like to say here that we did a YOLO session quite some time back, and it is already available on the CellStrat YouTube channel. You can have a look there. It will
So
not be possible to have a
about
repeat of the same.
is
Sorry?
I want to say something about YOLO detector. Okay, so YOLO detector, I will say this is most like what you say, one of the computer. Okay, so if YOLO is advanced, okay, advanced technique.
Your
The
your voice is
is
not audible, yes.
hello, is it
The
audible?
internet is bouncing actually.
Okay, okay.
So any other questions here?
Hello, is it audible now?
Yeah. So I don't see any other questions coming. So we would like to close it here and
Okay, thank you so much.
have a good day to all in India and rest of the world. Thanks, Yash.
Okay, thank you so much, everyone. Okay, thank you for giving this opportunity.